Howdy, my name's Matthew. This is Tyler, and that's Fatima. And today we're going to go over the Exxon Valdez oil spill, which was one of the biggest oil spills in American history. So, to give a brief introduction, this happened on March 24th, 1989, just after midnight in Prince William Sound, Valdez, Alaska. And the event that happened was the Exxon Valdez tank ship grounded on Bly Reef, resulting in 11 million gallons of oil spilling into the Alaskan Gulf. The- This resulted in damage to the environment, property damage to the vessel, the reputation of the company, as well as others involved parties, as well as the logistics of the port due to it having to close down for the cleanup. The reporting party is the NTSB, the National Transportation and Safety Board. And the proximate cause of this event is the navigational error by the third mate. And since this is a human error, we'll go deeper into the root cause. And we'll be looking at the first 24-hour failures, and these failures resulted in decades of cleanup activity. So now that I've given a brief introduction, Tyler is going to go over the timeline of the accident.
Thank you, Matt. On March 23rd, 1989, the Exxon Valdez departed its berth at the Alyeska terminal in Valdez, Alaska at about 9 p.m. Soon after departing, the master of the ship left the bridge, leaving the state pilot in command of his ship. The pilot, assisted by the third mate, safely navigated the ship through the Valdez Narrows and departed the ship when it reached the Coast Guard assigned travel lanes at about 11:25. The master returned to the bridge and made the decision to turn the ship southward to avoid ice in the travel lanes. After ordering the turn, the master left the bridge and the navigation of the ship was left to the third mate and an inexperienced helmsman. As the ship departed the travel lanes, the third mate was to execute a turn to bring the ship alongside Bly Reef and shoot the gap between the ice floe and the reef. By about 1 minute after midnight, the vessel had not turned and it crossed into the red sector, an area of shallow waters near the reef. The third mate ordered hard right rudder to avoid the reef, but it was too late, and the ship grounded on the reef at 9 minutes after midnight. Only then did the master return to the bridge and the accident response began. The grounding of the Exxon Valdez resulted in damage to all but 3 of the cargo tanks, and all the oil that would leak had done so within the first 2 hours of the accident. It took nearly 15 hours before response equipment could be brought onto the site, by which point the available equipment was insufficient to deal with the magnitude of the spill. The total value of the leaked oil was only about $3.4 million, but the damage to the ship was roughly $25 million, and the resulting cleanup activities would cost nearly $2 billion and are still ongoing today, 34 years later. I will now turn it over to Fatima to discuss the NTSB findings and to introduce our analysis.
Thanks, Tyler. There were 4 probable causes per the NTSB report. Exxon failed to provide a fit master and a sufficiently rested crew. There was a lack of effective manning and equipment levels for the vessel traffic service, VTC. There was failure for the master to provide a proper navigational watch because of alcohol impairment. And then we had the third mate improperly maneuver the vessel due to fatigue and excessive workload. It is also important to note that the third mate had been working for 17 hours straight, and per CDC, that is roughly the blood alcohol level of 0.05%. Here we have the methods that we used. We have the event sequence diagram. We used the Swiss cheese as well to support our diagram. And then we did 2 bow tie analyses, one for the event that occurred in 1989 and what if the event would have occurred in 2019 and all the barriers we have. Slide. So here we have the event sequence diagram. You could see the initiating event is ice in travel lanes, and obviously the master diverted to avoid the ice. There could have been different events if he would have not chosen to do that and gone the other route and navigated through the ice. As you could see, you could have a different end state. Then what happened next was the VTC had out-of-date ice reports and they were not able to monitor the vessel on the radar. Obviously, the master was under the influence of alcohol and he did not reduce speed, which was a lapse. Slide. So not only that, he left the third mate in charge, who was pretty exhausted, and he had a slip where he made a navigational error. And by the time he realized that he'd made a navigational error, it was too late. And the vessel ended up grounding on Blythe Reef. 11 million gallons of oil was spilled into the ocean. Slide. Here you could see the Swiss cheese diagram. We actually have a similar barriers. These barriers, as you could see, are all administrative controls, which are the weakest type of controls. They're not really warning systems or safety devices here that were available at that time that the system used. Ideally, we want to have redesigned to have better controls overall for this. Slide, please. And now I will hand it over to Matt.
Thanks, Fatima. So we're going to go over the bow tie analysis at the event of 1989 and the threats and preventive barriers in place at that time. So our first threat is navigational errors in congested and shallow waters. So some barriers include the trained crew, having a federal licensed pilot on board navigating the narrows, the traffic lanes to make sure you stay in the green zone, a VTC monitoring, as well as onboard instrumentation. Some big escalating factors for these barriers would include reduced manning. So if there's not enough crew members to monitor all the devices, well, this weakens that barrier. Additionally, the VTC could lose the vessel, like loss of detection on the radar. Either they're out of the narrows or the radar is malfunctioning. And this can cause significant errors when coming to evaluate where the ship actually is. So moving on to other threats of the bow tie analysis, we have vessel physical impact. And at that time, we only had single hull tankers, which provides one layer of defense, as well as we had pressure equalized loading, which basically means you don't fill up the tanks to full capacity, thus letting seawater come into the tank rather than oil spill out of the tank if there is impact with the tank. And lastly, we have ice in our traffic lanes. So you have your radar system to detect ice. And finally, we have the VTC ice reports. However, they could be out of date. And this is because vessels would report the ice to the VTC, and then the VTC would then relay it back to the vessels in the area. So now that we've gone over 1989, let's go over to what is currently in place as of 2019. So some of the changes include having an escort service, which reduces the risk of navigational errors. There is also reduced work hours for the crew, thus making them not have fatigue. There is required alcohol test for anyone that is suspected of using alcohol. There's also just an overall improved safety culture there since the incident. And finally, there is improved radar detection of the VTC. It's more state of the art. And so let's move on to the second part of the 2019 version. So again, we have our escort service, which helps mitigate the threat of ice. The VTC can now monitor the ice a lot better. However, there's not actually a lot of ice in that area anymore due to it melting due to global warming. And finally, we have our biggest barrier, which is double hull tankers. So if the ship is struck, it will have to go to 2 layers of defense rather than just 1, which significantly reduces the risk. So now we've talked about the threat side of the bow tie analysis. Let's move on to the right side of the analysis, and Tyler will be mentioning all of that.
Thanks, Matt. The Exxon Valdez spill was the largest tank ship spill in U.S. history, not because of any special circumstances leading up to the event so much, but because of the poor response to the spill in the first 24 hours. A number of mitigations existed for the environmental damage from an oil spill, such as response plans and drills, and equipment such as containment booms, oil skimmers, oil dispersant chemicals, and in situ burning. Additionally, a lightering operation within the first 2 hours of the spill would have reduced the loss of cargo and therefore the amount of damage to the environment. Unfortunately, in 1989, the Alyeska terminal only had 1 barge for cleanup equipment, and that barge was not loaded and had sustained damage in a recent storm. Because of all that, None of the equipment was available within the first 15 hours, and by that point, the equipment that they did have was insufficient to clean up the oil that had spread throughout the sound. Chemical dispersants might have been used, but there were no clear procedures for those, and the calm seas prevented them from being effective. Similarly, in situ burning may have helped in the response, but this required approval from the state, which was not received until the day after the accident, at which point the oil was too spread out to burn. Today, significant improvements have been made to the oil spill response assets in Prince William Sound. While in situ burning and chemical dispersants are no longer options due to their own environmental impacts, Alyeska, the oil companies, the Coast Guard, federal, state, local, and citizen advisory councils have contributed to making stronger response plans with clear chains of command. Additionally, as the primary responder to an oil spill in Prince William Sound, the Alyeska terminal now maintains barges of response equipment at numerous locations throughout Prince William Sound and the local communities. These barges are manned 24 hours a day by dedicated response staff. And additionally, Alyeska has contracted every fishing boat in that area as emergency response vessels, which can be called up immediately upon the report of a spill. Major response drills are now practiced twice annually, with smaller drills throughout the year. The goal of all of this is to ensure that the equipment and the personnel needed to effectively respond to a major Exxon Valdez size spill are on site within a meaningful time to clean up any spilled oil. Additionally, as Matt mentioned, the requirement for double-hulled vessels in Prince William Sound significantly reduces the likelihood of a major spill like the Exxon Valdez and can serve to prevent large quantities of oil from being lost in a spill. In conclusion, the grounding on Bly Reef could have been prevented. Alcohol played a major role, as did the degradation of the Coast Guard's VTC service. The response to the spill was inadequate and ineffective. The failures in the first 24 hours led to decades of cleanup. And the lessons learned have improved vessel safety and oil spill response. But accidents like the Exxon Valdez could still happen. Though they're much less likely to result in long-term cleanup activities with major environmental impacts. We thank you for your time, and we look forward to answering any questions you might have.